Alright kids, so today we are going to go through how to do dilution not just how to do dilutions, but how to do the calculations, and this is what we're after an understanding of today. Okay, so by the end you should be able to explain what a dilution is, and you should be able to calculate the concentration of a solution made from an original stock solution, which we see an example of here. There's one made by someone in our class, and here's the stock solution, and each one of these dilutions was made, and it goes stepwise to weaker, weaker, and weaker or less concentrated. All right. So dilutions, what are they? Well, basically, when something's diluted, the concentration of the solute is reduced. Now, the way we lower the concentration of the solute is by adding more solvent or taking a small amount of the solution and adding it to a large volume of solvent. Either way, you're adding more solvent to the solute and you dilute it that way, which means there is less solute per unit of volume for the solvent. Now, when we do a serial dilution, which is what we did there, what we're doing is we're doing a stepwise dilution of a substance in solution. So basically, we take a small amount and we put it in here, and then we take the same amount here again and we put it in here, and we take the same amount again and we put it in here, and you top up the volume to the same level. Okay, so often the dilution factor, well, actually, to be a serial dilution, the dilution factor at each step is constant, has to be constant, and this results in like a geometric progression of the concentration downwards, so that you get that sort of in a logarithmic fashion. Now, a logarithmic fashion usually means it goes down or up by a factor of 10 each time. Not always a factor of 10, but in this case, it was. So, the concentration decreases by the dilution factor each step. So if you make a 1 to 10 dilution and you your stock solution and then you put it in there, so if the concentration here is, we'll say 5 moles, that's the last time I'm running this, moles per liter, the next one will be 0.5, the one after that will be 0.05, 0.005, and so forth down the line. All right. So how do we work out what happens to our dilution, like the concentration of it? It doesn't have to be a serial one. We use this formula here. Okay. So, all right. Basically, we can rearrange this. So the numbers we should know before we start are C1. So we know this one. That's a known, and that's a known. The only one we don't know is the concentration of the new dilution. So we've got our original dilution. So here's our stock bottle, and here's our first dilution, or the only dilution if that's what we're doing. We want to know the concentration in there. Now, you rearrange this formula to get C2 on its own, and you do this by dividing that by V2. All right, so what are they? Now, C1 is the original concentration. You'll probably have to work that out. That's usually the first step. V1 is the volume removed to dilute. So here's your stock bottle. If you take out 25 mils of that, then V1 equals 25 mils. Okay, so whatever you take out of that original stock solution, that's your volume 1. V2 is the total volume of the new solution. So when you put it in your next volumetric flask, if it's 250 ml, then V2 is 250 mils. So whatever that next volume is. And C2 is what we're trying to work out. Now, let's do an example. Okay, so if we've got 1 gram of sodium chloride, we dissolve it into 250 mils of H2O. Basically, what's the concentration of the first serial dilution? So it's 1 to 10. All right. So first thing we need to do is we need to work out the concentration. So concentration, as we know, is N over V. so that's moles over volume, and that's gives us moles per litre. We need to know what the moles are, so to work out the moles, so you see how our complications are getting more and more, our calculations are getting more and more complicated with each new thing we put on. They all add together. Okay, so moles is mass divided by molar mass. So it's 0.1 grams divided by 58.44 grams per grams per mole. And this gives us 1.7 times 10 to the minus 3 moles. Okay, so if we put that into our C equals N over V, so that's in there, we know what N is and we know what V is. V is 0.25. There we are, because it's 250 mils, so 0.25 a litre. That gives us our concentration. All right, sweet. So that's not so hard. Now, the next step, we go to our second formula. Actually, it's our third one at this stage. So C1 equal C1 V1 equals C2 V2. Rearrange it. Okay, so this gives us 6.8 times 10 to the 3 times 0.025 divided by 0.25, which gives us 6.8 times 10 to the 4 moles per litre. Now, this here is a serial dilution, okay? So that actually makes it very easy for us to check out working, because the only thing that should change is that number there overall. That's the number that should change, okay? We should go down by a factor of 10. However, if you do this in an exam, and you will do this in exams, I want you to make sure that you show you're working. All right, so that's us. And I hope that makes sense on how to show you're working for some of you who struggle with that. First you write down the formula, then you fill in the numbers you know, and then you write down the answer for that level, and that's where we go. Okay, so the first thing you do is you work out the concentration for C1. You might have to work out the moles, and then you plug all the numbers you have into that formula, and away we go. All right, see you.